Everyone. I wanted to make this video because I realized that I didn't show you how to find the standard deviation in 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 Codap. So go ahead and go to Codap, or if you're not in front of if you don't have the ability to do that right now, you could just follow along and do this later. So go to Codap. Codap has a few data sets that are built in. So I'm going to go to Open Document or Browse Examples. And down at the bottom, roller coasters, I'm going to click on that data set, open it. Okay, so you can read a little bit more about the roller coaster data set here, but basically it's 157 roller coasters throughout the US. Variables include the name, the park, the city, max height, drop, if it has inversions or not, so on and so forth. And then there's another grouping over here, the age groups, older, recent, and newest roller coasters. So we're going to make a graph. I'm going to just get rid of this so we're not distracted by it. We're going to make a graph of the top speed of the roller coasters. So I'm going to click down here, add the top speed variable. Okay, so here's my top speed dot plot for the 157 roller coasters. It's a roughly symmetric distribution with some possible outliers out here. It's somewhat skewed right. The peak is a little bit further to the left than the center, so it's not perfectly symmetric, but it's symmetric enough for our discussion here. So just a reminder of the things we want to look for. When a distribution is symmetric, the measure of center is the mean, x bar. The measure of spread relative to the mean is the standard deviation. We write S sub x. The typical interval are all values within one standard deviation of the mean. The idea there is the mean is the typical value. The standard deviation is approximately the average distance from the mean for the values. So in other words, it's the typical amount of variation we see in a data point relative to the mean. And so if I go one standard deviation below the mean and one standard deviation above the mean, that's what this interval here is defining, then I get all values within one standard deviation of the mean. So that is our typical interval. That's how we're going to define it when we use the mean and standard deviation. And then finally, outliers or unusual values are values that are more than 2 standard deviations from the mean. So either values less than x bar minus 2 times standard deviation of x, or larger than x bar plus 2 times standard deviation of x. Okay, so if we go back here, if we click on the ruler icon, I'm going to click mean, and I'm going to click standard deviation. You might have already figured this out by now. Okay, so if we hover over the center line, that's the mean. Mean is 58.6. And if we hover over the right or the left end of this shaded region, it tells me the standard deviation, 14 miles per hour in this case. So this line on the left, this is 14 miles per hour below the standard deviation, below the mean. And this is 14 miles per hour above the mean. Okay, so it looks like, this is around 45 or so miles per hour, and this looks like around 75 or so miles per hour. And notice if we had just picked a typical interval just by sight, that's around the speed, that's around the typical interval we might have picked, probably from 50 to 70 or so. Okay, so how we're defining the typical interval jives with what we kind of intuitively would probably say here. Okay, so let's add some words to our analysis here. The roller coaster top speed distribution. Okay, the top speed of roller coasters is a roughly symmetric distribution. The typical roller coaster has a mean top speed of 58.6 miles per hour. The typical roller coaster varies by a standard deviation of 14 miles per hour from the mean. Therefore, the typical interval of roller coaster top speeds are all coasters within 14 miles per hour of the mean. So here's the calculation for that. There's the mean minus a standard deviation to the mean plus the standard deviation. That's what defines the endpoints of our interval. So that is from 44.6 miles per hour to 72.6 miles per hour, which is, about what we estimated just by looking at it. Okay, so that is a typical roller coaster speed, and this number is a typical amount of variability we see in the data. Okay, so let's add another layer to this. Let's say we want to add a categorical variable to split the data into two dot plots to make a comparison. So the variable I will look at is down near the bottom, inversions, and that is whether the roller coaster has an inversion or not. Inversion meaning just if it goes upside down or not. I'm going to add that. So I got my yes inversions up here, my no inversions down here. Okay, let me unclick these items for a second. Okay, so looking at them, they look like roughly symmetric distributions. They look like they probably have a similar center. But that the no inversion group has more overall variability and probably more variability relative to the mean as well. Okay, so let's see what that means when we actually look at values. So there are the means pretty close together, 57.6 miles per hour for the roller coasters with inversions, 59.4 miles per hour for roller coasters without inversions. A 2 mile per hour difference in top speed isn't a lot, doesn't seem like very significant. We will know for sure really when we look at the standard deviation. So let's click on that. Okay, and let's look at the values. Standard deviation for the roller coasters with an inversion is 9 miles per hour, and the standard deviation for those without an inversion is 17 miles per hour. So we got this 2 miles per hour or so difference in the means, but relative to how much variability we see within each distribution, that is not very much, right? We typically see a 9 mile per hour variation for a roller coaster for the inversion group, and at 17 miles per hour, even more variation in roller coaster speed from the mean in the non-inversion group. So a 2 mile an hour difference between the means is not that significant compared to how much variability we see within each distribution. So yeah, so this is kind of verifying what we thought. Similar shape, similar means, but you know what? A lot different variability. 17 miles per hour of variability down here compared to 9 miles per hour down up here. So there's a lot more variability in the no inversion group, both overall variability, if I'm looking at the overall range, and also relative to the mean. Okay, so let me add some words to our discussion here. Maybe this is a good time for you to pause and write something down. Write down what the typical intervals are and what the standard deviation tells us, and anything that comes to mind in terms of just comparing these distributions. Okay, so now that we're back, this is what I wrote. If we separate by whether the coasters have inversions, we see that both distributions are roughly symmetric in shape, with similar mean top speeds, 57.6 miles per hour for coasters with inversions and 59.4 miles per hour for coasters without inversions. These are not significantly different if we take into account how much variability there is relative to the means. The coasters with inversions typically are within 9 miles per hour of the mean, and the coasters without inversions are typically within 17 miles per hour of the mean. This tells us that the coasters without inversions have significantly more variability compared to coasters with inversions. By the way, that makes sense in context if you think about it. If your roller coaster doesn't have inversions, it can go slow or it can go really fast. But if your roller coaster does have inversions, it can't go that slow because that would be dangerous to do an inversion going too slow. And it can't go that fast because if you're doing an inversion going too fast, it'll probably make the passenger sick. So it makes sense from an engineering perspective why this group has more consistency, less variability. Okay, anyway, where was I? This tells us that the coasters without inversions have significantly more variability compared to coasters with inversions. Finally, the typical interval for coasters with inversions, and this is where I did the calculation, right? Mean minus the standard deviation, 48.6, mean plus the standard deviation, 66.6 miles per hour for the inversion group. which is completely contained within the typical interval of the coasters without inversions at 42.4 to 76.4 miles per hour. Again, that's this mean minus the 17 miles per hour and then plus the 17 miles per hour there. Despite similar shapes and mean top speeds, the coasters without inversions have more variability, including the slowest and fastest coasters in their distribution. Okay, well, I hope this has helped. I hope you've learned a lot. Please let me know if you have any questions or if I've made any mistakes in this video. I'd love to hear from you either way.